The story of Florence Nightingale has gone down in legend. The lady with the lamp, the ministering angel of the Crimea. She was already an idol in her own lifetime, but 100 years after her work in the Crimean War, children were still reading books like this one, which I had as a child, the Ladybird book of Florence Nightingale, with the story of the lady with the lamp, who as a child had made hospitals for her dolls and then grew up to revolutionize nursing and reform public health and change the world. So such stories are, all very well as far as they go, and they are true, but they, for me, miss the most important question, which is, how did she manage to bring about those changes? How did she do it? And the answer is, she did it with data, with statistics, and particularly with the innovative use of statistical diagrams, like this one, which is probably the most famous of her statistical charts, that tell a story in such a compelling way that it's impossible not to get the message and it's impossible not to act. So today, I want to explore with you the mathematical life of Florence Nightingale. What she did, how she did it, how it fits in with the story of statistics and statistical diagrams that goes through the 18th and 19th centuries to the present day, and how her message about data is still relevant to us today. And along the way, we'll be counting all the animals in the zoo, we'll be weighing a mountain, and we'll be sabotaging the economy of France. Sorry, France. Nothing I can do about it. But to begin with, who was Florence Nightingale? Well, she was born on May the 12th, 1820, to a wealthy family. She had an older sister, and they were both named for the city of their birth. So Florence in Italy, and her older sister was born in Naples. Now, Naples isn't particularly a pretty name for a girl, so instead they chose the ancient Greek name for Naples, Parthenope. So those were the two sisters. And they were both very intelligent, articulate girls. Florence, from the beginning, loved data, loved numbers. This is a picture of her as a young woman with the best pet in the world. She had a pet owl, which I love her for already, and this picture was drawn by her Parthenope, her sister. Now, we've got some letters from the young Florence as a child that show her love of numbers and data right from the beginning. And these are charming things. So on the top, I've typed the words. So she writes to her grandmama, the baby's pretty, gone, not interested in the baby. What she's interested in is listing every single animal, how many there were, when she went to the Zoological Society. So she went to the zoo, and she is saying, I've got all of these things, 3 of those, 4 of these. The llamas get categorized into a brown one, a white one, and a small brown one, and all of these other things. So she's listing, and she's remembered how many she saw, and that is information to her that is important enough to tell grandmama about. The one underneath, which very neat handwriting for Florence, well done, but she is writing to her older sister, and she's saying, look, we are sorting out the larder. And she has got a table of data in this letter. She's sorted into vegetables and fruits. She is categorizing the vegetables. She's got little ones, in that category goes potatoes, and then long ones, cucumbers go in that category, and then peas, they go into kind of dainties. So, okay, maybe not an entirely professional taxonomy, but the point is she's doing this because she's interested to sort things out, put them into order, categorize her data. So as she got older, what was Florence Nightingale going to do with her life? Well, the expectation for a young lady of her social class and standing was you marry, you have a family, you reign in the domestic sphere. But she didn't want to do that. She wanted to go beyond that, and she decided she wanted to be a nurse. Her parents disapproved because nursing was not considered an appropriate activity. It wasn't a profession. A young lady of her class would not typically become a nurse, and they were against it. But as we'll see in the course of this lecture, when Florence Nightingale decides she wants to do something, it quite often happens. So she became a nurse, and by 1853, we find her as superintendent of a hospital for gentlewomen in Harley Street in London. But it was what happened soon after that, the Crimean War, that really was a pivotal point in her life. So the war in the Crimea, which was between Russia and then an alliance including the Turkish Empire, the Ottoman Empire, and Britain and France, was perhaps the first conflict where reporting from the front line could get to the home countries and appear in the newspapers and actually cause changes in policy. So reports came back, and there were newspaper reports of the awful, appalling conditions for soldiers at the military hospitals in the Crimea. And this is a picture of one of them. You see Florence Nightingale in the middle there, the lady with the lamp, at Scutari, which is kind of the worst of these hospitals in terms of conditions. So when reports got back, that the conditions are awful, loads and loads of soldiers are dying in these hospitals, something had to be done. There was pressure, because of these newspaper reports, on the government to do something, to act quickly. Now, Florence Nightingale happened to be a friend of the Secretary of War at that time, Sidney Herbert. And almost like their letters crossed almost. She wrote to him saying, "Let me go out there, I can help." And he wrote to her saying, "Please, will you go out there, you can help." So that's what happened. She took a group of 38 women with her to the Crimea. It was the first time women had been allowed to serve in any kind of official capacity. They went out there, and indeed, things were really, really awful, beyond anything we could imagine. I mean, when I say that the hospitals were dirty, there were rats running under the beds, there were almost open sewers, there was no drainage, there was no sanitation, no ventilation, there were, in the street outside, and there were dead dogs and even dead horses that were just left to rot in the streets. The conditions were terrible. For this hospital, Scutari, which had about 2,000 soldiers in it, usually, in that entire hospital, there were no basins for washing, and there were only 14 baths. So it just was impossible to get clean and to stay clean. And Florence Nightingale and these 38 women kind of set to straight away to try and do something about this. And they pressed for kind of cleaning up, better sanitation in general. Finally, in March 1855, a sanitation committee came out to Crimea, and they cleared up, the problems with the drainage. They fixed the overflowing sewers, right? This is how awful it was. They started to fix that, and then things improved. It took some time, but things improved. When she came back from the Crimea, Nightingale wanted to report on what had happened and what had changed and what had worked. And she produced long, detailed reports full of facts, data, information. Here is what's happened, here is the information, here is the detail. But she also produced charts and pictures to illustrate the points that she wanted to make, what she had seen from the data, what was it telling her. And at the time, it's perhaps not what we might take from it, because we all know that hygiene is important and that there are diseases that can be prevented with good hygiene and sanitation. At the time, this was before the germ theory of disease, people didn't necessarily think there's anything we can do about certain kinds of disease. You get cholera, it's bad air, or it's miasmas. So washing your hands in that situation is not going to help with bad air. So the argument that had to be made, really, for that audience wasn't there's lots of disease. They knew that. There was lots of disease at home as well. It was actually, look, when we cleaned up, things really, really improved dramatically. So this was the argument she wanted to make, and she did it by assembling a lot of data, but also then by showing that data in brilliant visualizations. So we're going to kind of go through, I think, the three things that make Florence Nightingale a brilliant statistician. And we can always have this message in our minds, even today, when we're thinking about what we do with data, what will Florence Nightingale do with it? And so there's three things. The first thing is you've got to make sure your data is robust. You've got to have the right numbers, the right information, gathered properly and consistently. The second thing is when you've got your data, you've got to know how to interpret it. What do these numbers actually tell us? And finally, if I've got a message I want to get across, what's the best way to do it? And Florence Nightingale was brilliant at choosing great images that tell a wonderful story. So we're going to look at these three things in turn. But to put it in some context, I want to just give you a couple of minutes on where statistics was at Florence Nightingale's time and just before. Where do you even get that word statistics? So the word statistics does not enter the English language, I think, until about 1791, with this chap, John Sinclair, looking very dashing there. He wrote a statistical account of Scotland in 1791. He gathered lots of information. He'd written to sort of local worthies all around Scotland. How many people are dying? What are they dying of? What are people doing with their lives? He wanted to measure the quantum of happiness, as he put it, of the Scottish people, which is a lovely phrase. I don't know what the answer came out as. Hopefully it's constantly improving. But he was the first one to use the word statistics, I believe, in English. But earlier there was a word in German, Statistik, spelt with a K, that kind of means the science of the state. And that gives a clue to its early use. It's numbers and data to do with the state, with the people living there, with the money, with the income, outgoings, exports, imports, births and deaths. That kind of number. And it was called in England beforehand political arithmetic, which is an interesting phrase. Then you start to get this phrase vital statistics. And this is things like, what's our population? What are people, who's being born, who's dying, marriages, things like this. It was not data that was being routinely collected. The first census in England and Wales was 1801. Of course, there's been the concept of a census goes back thousands of years. I mean, it's there in the Bible and everywhere else. But there was the official census in England and Wales began in 1801 and has been running every 10 years since then. There was opposition even to doing this census, even to knowing what our population is. Because people said, well, what if the population turns out to be less than we've been telling people, and then our enemies will be encouraged and think we're weaker than we are as a nation, and so maybe they'll invade. So this was felt by some to be a risky thing, even to know your population. Happily, those people did not win the argument, so we had the census. But it wasn't until 1836 that there started to be a national record of even births and deaths. Before then, there were parish records and things like this, but it was sort of all over the country. There was not a single place where this data could be gathered. And so, if you don't have the data, you can't do anything. So it was through the work of statisticians like William Farr, who also worked with Florence Nightingale quite a bit, that these kind of numbers started to even exist, and that we knew them. Then over in France, at sort of a same-ish kind of time, you start to get moral statistics. So here's a picture from a book by André Michel Guéry, which came out in 1833, and this was the moral statistics of France. So this had things like crime rates, divorce, illegitimacy, and the one I've got here is education. So the literacy rates, and he's got kind of a chart of France divided into regions, and he's shaded them in according to the literacy rates in that particular region. So these then it's moving slightly beyond the sheer number of people you have and looking at qualities about the population, crime rates and things. Another thing that happened was that people like Adolphe Quetelet here, who was a Belgian astronomer, statistician and sociologist, started to get interested in characteristics of perhaps, the human body. So average heights, average weights. He came up with this concept of the average man. And he also gave us, which we may or may not be grateful for, what's now called the body mass index, that your doctor will tell you off about for being too high or too low. So we don't know how we feel about Quetelet, perhaps. But this idea of averages, then, is coming from sciences like astronomy, where it's quite natural to take an average of several readings, perhaps, then if you take the average, you hope to get a more accurate answer because you're trying to eliminate random errors. When people started to talk about averages in terms of figures like crime rates or deaths or even, what people's body composition, this was greeted again with suspicion and concern. People really worried about these numbers that you're associating, these moral statistics that you're associating to a population. How can you say that there is a particular murder rate that you know is going to happen this year based on previous data? This worried people, and it was a topic of fairly general discussion. So you get authors of the day engaging with these questions, like Charles Dickens. He was very worried by this. He said, if the number of people killed so far this year is below the annual average, he says, is it not dreadful to think that before the last day of the year, some 40 or 50 persons must be killed? And killed they will be. I think you just picture this thing of, right, you, and you. The numbers are down a bit this year, come with me. So, he was genuinely worried about, and this sort of tension between individual choices made by millions of people versus what these tyrannical numbers are trying to tell us and make us do. So he has this sort of suspicion of data. Someone who I think was much better at mathematics than Charles Dickens, George Eliot, had a completely different view. And so this is a quote from her novel Daniel Deronda, but I think it probably reflects her own feelings about data, which is that they are not our enemy. They can be our friend. So she says it's no more wonder that quantities should remain the same than that qualities should remain the same. For in relation to society, numbers are qualities. So the number of drunkards is a quality in society. It tells you something about the society. The numbers are an index to the qualities. And give us no instruction, so it's, they don't force our hands to behave in a particular way, but they set us to consider the causes of the difference between social states. And that's the key thing. And that's the sort of thing that Florence Nightingale was doing. If you spot that, in this place, mortality rates are higher than they are in this place, that tells you it's not an immutable fact of life. God has not decreed that so many people each year are going to die of typhus. Maybe there's something we can do about it. And that's where the power of statistics and data can come in. So I mentioned three things that Florence Nightingale did. The first one, or three qualities of her thinking. The first is about, are we measuring the right thing? Are we getting the right numbers? Getting good data. And there's several instances that we can look at where she would see data that was being presented or numbers that were being presented, and it was the wrong number to think about. And I'll give you an example of this. So I'm paraphrasing here, but when she was campaigning for the professionalisation of nursing, she wanted nurses to be trained. And indeed that started to happen, and there were training schools for nurses, but some people who did not like changes to the status quo, thought only doctors should be in charge, nurses shouldn't be doing anything, said, wait a minute, we've looked at the mortality rates for patients being looked after by trained nurses, and it turns out more people are dying, there's a higher mortality rate under the trained nurses than under the untrained ones. So clearly training nurses is a terrible idea. So again, here's my paraphrase of what Florence Nightingale might reply to this, and she engaged with this, people genuinely said this, and her response was, you idiot, she didn't say that, in a very polite Victorian way, she said, okay, no, this is wrong. The problem with this kind of thinking is, you are not comparing like with like. The underlying populations are not the same, because who do you think we're going to give the sickest patients to look after? If someone comes in and they're incredibly ill, do you give them to the one who is an expert and a trained nurse, or do you give them to the untrained, the inexperienced nurse? Of course, you're going to give the sickest patients, the ones who need the most expert care, you're going to give those to the care of the nurses with the most experience and training. So what that means is, you're not comparing the less trained or untrained nurses are getting given a healthier population on average. And so, of course, even if the trained nurses are improving outcomes considerably, you might still expect that a higher proportion of those very sick patients might die. So you cannot make that conclusion because you've got different populations that you're considering. You're not comparing like with like. So this kind of thing, nowadays, when we're doing medical statistics, if you're comparing, say, the performances of surgeons, of course we know this. If you're looking at a heart surgeon who's doing very risky operations, we do not expect them to have the same survival rates as someone who's doing routine tonsillectomies or something. So we know this in medical statistics. But there are still, unfortunately, the age of the idiot is not over. And it can have severe, important implications for policy, like really important implications. I'll give you an example. In October 2020, the then Prime Minister, it was reported in newspapers that he'd sent this WhatsApp message, right? And he was, this is thousands are dying, right? And he's sending this flippant little thing about, I've been rocked by the fatalities because the median age of death is 82, and 81 for men, 85 for women, and that's above life expectancy. So you live longer if you get COVID. Ha, 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 right? Okay, let's reduce the blood pressure. So let's pretend Florence Nightingale is on this WhatsApp conversation. What's she going to say to this? She might say something like, "You idiot. You're not looking at the right numbers here," right? This life expectancy that he's talking about, that's at birth. So let's suppose that the men do have a life expectancy of 81, let's say, that would mean that half of the male babies born can expect to live to 81 or over, and half will die before then. But if you make it to 81, then by definition you have not died. You haven't died in an accident or of a childhood disease. You have made it to that point, and so at that point your median life expectancy is not 81, like we don't all drop dead on the day of our 81st birthday. Your life expectancy is more than that, right, because you've made it that far. So at 81, a man at 81 has a life expectancy of 89, and a woman at 85 has a life expectancy, on average of 92. So it's actually been calculated or estimated that every death from COVID lost 10 years of life for that person. So yeah, this is what Boris Johnson said, flippant and wrong, but it did affect the policy at the time because they genuinely thought, it's only the people who were just about to die anyway who died. And that affected their decision-making processes and with bad results. Another thing that Florence Nightingale was really hot on was about consistency of data and how often data was reported. So this next fact, again, at first glance, it might not seem to be anything wrong with it. So she was looking at information, data from a particular hospital, and she noticed they were listing the patients in the hospital and what was wrong with them once a week. So that's sort of taking a weekly snapshot. Now that might seem like, okay, fair enough, that will give you a rough idea of what's happening. The problem with this is slightly more subtle, and a good explanation of it, or a similar issue, is illustrated by this. You might have seen, it's quite a popular meme that you see online. Periodically, this picture will be shown. So this picture is based on, in the Second World War, they were kind of looking at when planes had gone out on missions, when they came back, where had they been damaged? So all these little blobs mark damage to the plane. And so there are various hotspots you can see. So then the question is, well, what do we do with this information? Should we reinforce those parts of the plane? These are where the most damage is happening. What do we do? And the really key observation here is to say, okay, what are we measuring? What are we looking at here? What is our sample? So we're looking at the planes that have come back from missions, and wait a minute, we're looking at the planes that have come back from missions. Come back. We are not looking at the planes that have not come back. Why haven't they come back? Because the damage to them was so significant that they did not return. So if this diagram tells us anything, it tells us where it's okay to be hit, and you'll still be all right. So this diagram almost tells us the opposite of what it looks like at first glance. Now, something a little bit like that is happening with the once-a-week census. It feels like just a snapshot that will give you the general picture. But there are two groups of patients who are going to be underrepresented in a weekly snapshot. The one group is basically fine, they've stubbed their toe, they go away again after a few hours. They're underrepresented in a weekly snapshot. The other one, at the other extreme, is the very, very sick patients who only live a day or two. And so those ones, there'll be some of both of those groups in the Tuesday count, but they will be underrepresented compared to the ones who are staying for a long time. And so you're not getting a random sample of the data there. Okay, so here are some of the ways in which we can perhaps get the wrong numbers, get the wrong information, and Florence Nightingale was really, really good at spotting those accidental errors. Once you've got numbers, you have to interpret them. So here's another thing that she was really great at, and that others perhaps were less great at. So here is, I don't want to say a pompous ass, that might be a bit mean, but Brigadier General Lord William Paulet writes to his boss from Scutari in the middle of the worst bit of the Crimean War. And he's delighted to say how marvellous everything is. Everything is progressing under my command. It's progressing as favourably as I could wish. Sickness has very much diminished. So has mortality. In January, the number of deaths was this much. In February, it's going down. Everything's amazing. I'm amazing. Give me another medal. So let's paraphrase Florence Nightingale's reaction to that. You idiot. So here's what's happening. Yes, the absolute numbers of deaths have decreased, but that tells you absolutely nothing if you don't know how many people there were in the army or in the hospital at that time. So what had happened here from January to February, the number of deaths, yes, had come down in absolute terms, but the number of patients had dropped even faster than that. So mortality rates had actually increased. They were increasing under the watch of this guy, and he didn't even know. Like, he probably genuinely was like, oh, good, everything's great. But no, mortality rates were increasing. Things were getting worse. So, and she, spotted that. So you cannot make this conclusion. We don't know what the mortality rates are from this data. We cannot interpret it in the way you say. And this is a kind of thing that I call a what's the denominator problem. We don't know what the mortality rate is from this information. And you see this quite often, and if you've got your Florence Nightingale lenses on, you can spot this kind of mistake in newspaper headlines. There's two particular kinds of headline that we see that have similar kind of issues. So this is the kind of headline, a new sport that you've never heard of, and apparently everyone's now doing it, and you read, underwater darts is Britain's fastest growing sport. Now what that usually means is that Bob has invented underwater darts and is very excited about it. So there's one player of underwater darts. And then Bob gets his two friends to also become underwater darts players. So now the headline can truthfully but misleadingly say, numbers have tripled of underwater darts players. And when you see that kind of headline, almost always what it means is, this is an extremely small sport played by hardly anybody. It's the only way numbers can triple. So that's one example. The other one is slightly more kind of important sort of headline, but we regularly see headlines to the effect of some food is going to kill you. Bacon has been a recent one that's going to kill us all. Why will bacon kill us? Well, there is an underlying nugget of truth here. There have been studies that shown that if you eat 2 rashers of bacon every single day for your whole life, that your underlying risk of getting bowel cancer at some point increases by 18%. But the thing is, it's your relative risk. So the question is, compared to what? What's the actual overall risk of getting this kind of cancer? And the baseline risk of getting bowel cancer at some point in your life is about 6% currently. So this 18% rise, it doesn't mean if you eat bacon every day, that's going to be 24%. It's a relative rise, so it rises by 18% of 6%. So what this really means, what the report, the scientific data tells us currently, seems to be that the increase of risk it goes up to about 7% if you eat bacon every single day. So that's not nothing. There is an increase, but it's not, the kind of headlines we see where every food is either going to kill us or cure us of all diseases, those are really not very helpful, because if we know that information, we can then decide for ourselves, can we cope with that risk? Maybe if we think, okay, I don't want to increase from 6% to 7%, okay, maybe you have a bacon roll once a week and not every single day. But with the data, we can make an informed decision. But the kind of, 18%, oh dear, that's less helpful. And to contextualize it, smoking increases your risk of getting lung cancer by a factor of 2,000. Not 18%, 2,000%. You're 20 times more likely. So, smoking really will kill you. Bacon probably won't. So yeah, that's hopefully good news. Okay, so we've got our data. We've made sure it's robust. We've made sure we are interpreting the data correctly. The final piece in the puzzle is showing our conclusions to the world communicating that information in a compelling way. And that is done quite often best through visual means. So I'll show you some of Florence Nightingale's brilliant data visualizations, but I just want to give you a few instances, historical instances, of my favorite bits of data visualization. And the first one is to do with this guy, Charles Hutton. So he was a mathematician, and in 1774, he went to this mountain, Schiehallion in Scotland, in Perthshire, and they were on a mission to measure, they wanted to know the mass of the world. They wanted to weigh planet Earth. Now, we don't have scales big enough to do that, so how can we find the mass of planet Earth? Well, we can find the volume of planet Earth because it's essentially a sphere. We know the formula for the volume of a sphere. You can make it a bit more accurate, but we can estimate the volume of the Earth. So if you know density, density times volume equals mass. So you can find the mass of the planet Earth if you know its volume, which we do, and if you know its density, which we didn't know. So how do you find the density? Well, what you can do is you can take a little bit of planet Earth, a mountain, for example, and you can find its density. So that was the plan. So how do you find the density of a mountain? Well, you can find the mass and divide by the volume. Simple. Only we don't know either of those things. So then what do you do? Well, for the mass, they chose this mountain very carefully because it's not kind of in a mountain range. It's sort of on its own in a relatively flat area. So what they did was they took pendulums up to Scotland, and if you're in a big flat expanse, the gravity that pulls the pendulum down will go kind of to the center of the Earth, and so it will hang vertically down. If you've got a big mountain here and nothing much here, then the pendulum will be just slightly deviated from vertical by the mass of this mountain that's pulling, it has a gravitational attraction. And you can measure that deviation, and with some calculations, you can work out the mass of the mountain that is causing that tiny amount of deviation. So they did that, and they got the mass. Now they need the volume. And here's where Charles Hutton comes in. So he decided the way to find the volume of this mountain was to essentially imagine it as lots of slices, and we're going to find the volume of each slice and then add them all up. So what about all these slices? So he walked all the way around the mountain lots of times, and he took lots of measurements of the heights at various points so that he got all these slices. And when he wanted to get a visual for these slices, what he did was to have all these points that he had, and he joined with lines the places of the same height, and thus contour lines. Now, it wasn't the first time that a chart had been drawn with joining things of the same value for some quantity, but these, we think, are the first contour lines, and you instantly, it's such a great idea because we can instantly look at an Ordnance Survey map or a kind of map with contour lines. We can see instinctively, the places where the lines are very close together, that's the steep bits when the land is increasing in height most quickly. So we can visualize from this map, you can get a really good instant idea of the topography of the landscape. So that's a really great little idea. That is instantly, you can see, fantastic way to visualize all that data about the different heights of the different pieces of land. We get onto kind of what we might think of as common statistical charts. They start to come in the end of the 18th century, start of the 19th century. And one of the key people in this story is a chap called William Playfair. And this is a diagram from his Commercial and Political Atlas, 1786, where he assembled loads and loads of data about kind of the economy, imports, exports, all these kind of things. Here is a bar chart. So it's not the first bar chart ever drawn, but it's an early bar chart. And again, you can see it's a really good way of representing the data. You can instantly see, look, these guys have we're doing a lot of trade with the ones at the bottom. And you can see there's a huge trade deficit with Ireland here. You can just instantly see that in a way that a table of figures is not necessarily showing you. But Playfair was quite innovative in his designs, so this is just an example, but my favourite bar chart of his is this 1821 chart, where he's measuring something we quite often talk about now. So we've got this bar chart and over time, and so the bars are representing the price of wheat, and it's going up a lot. So you might think, oh no, life's really hard, wheat's really expensive. But what he does, this is quite innovative, he's got a line The red line that he's drawn, which is also curving upwards, that's measuring the wages, the weekly wages of a good mechanic, it says here, so a sort of skilled worker, and those are rising as well. And they're rising faster than the price of wheat. And at the time his graph finishes, wheat prices have come down and the wages are still carried on going up. So he wants to make the point here that wheat has never been more affordable. So this is like a discussion of affordability, really, and that would be the next step. You could combine these things. But he's got both these things on the same graph. But what I like here is the explanatory text that he includes. He feels the need to include this shows that people were not comfortable with charts like this yet. Because he has to say, geometrical measurement, right? I know geometrical measurement has not any relation to money or time. Money and time are not spatial things, but it's still okay to represent them in terms of a picture. So he's sort of trying to justify it's all right to do this. We're making spatial things represent money and time. And of course nowadays we don't need to justify that. We're all okay with it, but this was the early days. So one kind of chart that Playfair does seem to have invented is the pie chart. So here are two early circular charts. And what's interesting to me is, this is 1801. The one on the right, this is proportions of the Turkish Empire that are in various continents. So you can see the typical slices of pie that we all know, Africa, Europe, Asia. So that's like a typical pie chart. What I like here is that the conventions are not yet set. Right, so these early examples, when he's looking at Russia, so this one, some of Russia is in Europe, some is in Asia. He hasn't got slices here, he's got concentric circles. Now, we don't tend to do that now with pie chart, but this is the very early examples. We're still deciding how we're going to play this one. So, yeah, Playfair included these kind of diagrams, and again, it really helps you to see visually the information that's being presented. This is quite innovative. Now, Playfair, things like pie charts and the statistical diagrams that he was using didn't catch on in England as quickly as they did in France. One reason for that was that Playfair was a bit of a wide boy. I don't know, he had some scandals. There was some get-rich-quick schemes. He may have been embroiled in various things. He did spend some time in prison. It wasn't a great look. And so people may perhaps have not jumped to adopt his really brilliant ideas as quickly as they may have done. But in France, where he hadn't, I don't think he was in prison in France. Maybe they were less aware of maybe the slight issues that in England. He spent lots of time in France. He took part in the storming of the Bastille. He was doing all the right things. The French may not. It's possible. Here's you can see there's some diagrams from a French book, Charles Minard in 1858. Lots of pie charts. They may not have been quite so keen on Playfair had they known that he was spying for England and that he had an idea which he executed to destabilize the French economy by faking loads and loads of French banknotes and then introducing them into the currency in order to make the real banknotes be worthless. And he did this, and it worked, and they had to abandon those kind of banknotes. So if the French had known that, they may not have been so keen on the old pie charts. They nicknamed them camembert, by the way, not pie charts in France, for obvious reasons. But anyway, they did catch on in France. It took a longer while for them to get to England. We'll get back to England. One final, since we've got a map here, I want to show you another map that's a real triumph of data visualization before we talk about Florence Nightingale some more. This is a very famous picture. This was drawn by John Snow right at the same time as the Crimean War, actually, 1850s. And this is a map of cholera cases in a particular area in London, in Soho. And each of those little black lines represents a cholera case. And he noticed that they were clustered around, sort of drawn this red dot here. They were clustered around a particular point, and that point was a water pump, the Broad Street water pump. And this kind of gave evidence to his idea that cholera is not spread by bad air or other things, it's spread by polluted water. And so they actually took off the handle of that water pump so that it couldn't be used, and cholera cases came right down. So this drawing showing these cholera cases, it shows you immediately there's a cluster. And that visualization is very powerful. Okay, so let's talk about what Florence Nightingale did. So we've established she didn't invent pie charts. That's a myth about Florence Nightingale. What did she do? So here's the picture that I showed you at the beginning. I'm going to talk us through it. This is the diagram of the causes of mortality in the army in the East. So in the Crimean War, the army is out there, it's fighting, and there are lots and lots of deaths. The blue regions are showing the deaths from what we now know are preventable diseases. And this was the case she was making. We can prevent these diseases. What we've got here is a circular diagram, and it's going through clockwise the months. So every kind of wedge is a month, and that's a good choice of diagram because we're quite used to looking at time in the form of a circle. You know, what's a clock? It's a circle divided into 12. So this is the months of the year. So it starts in April 1854, and nothing much happening the first 3 months. The fighting kind of started. Then we go round and we get various deaths from various causes. And then on the left, that's year 2. So that sort of dotted line leads us to April 1855, and then we go round again. We can see. So the detail of this we'll explain in a moment, but that's the basic idea. So let's talk through what she actually is putting in this diagram. What's the information in there? So as just a toy example, we know that we cannot just look at deaths in absolute numbers. We have to look at mortality rates. Otherwise, we don't know if we're just seeing fewer patients in the hospital because they've already all been killed, or whether it's a real improvement in treatment. So let's imagine this is a sample month of the data she was gathering. So for each month, she looked at what's the total size of the army at that point, because that's obviously very relevant. Let's say it's 40,000 at that point. So in this month, so there were 3 categories she had. So either people dying from their wounds in fighting, or of diseases which are actually preventable, like your choleras or typhus, that kind of thing, or everything else. So, if you have a heart attack, not much they could do about that at the time. So let's say 400 are dying from wounds, 800 from preventable diseases, and 200 from other causes. So then she works out the mortality rate per 1,000 men. So in the army of 40,000, if 400 dying in that month from wounds, that's a mortality rate of 10 for every 1,000 men, and the others similarly. And then she worked out this annualized number. So if 10 people are dying per 1,000 in a single month, then over the course of the whole year, multiplied by 12, and you get 120 deaths per 1,000 men from, in this case, wounds. So that's the data. Then how do you plot that on your polar diagram? So polar, there's a pole in the middle, and you're radiating out from it. So you draw these wedges. So for each month, that's 1/12 of the circle. And you're drawing a wedge for each of these numbers, and the area of the wedge is proportional to the number you're representing. So the area of, if you've got a circle of radius r, the area of one of these 12ths of the circle will be pi r squared over 12. So that area is what you want to be proportional to the number. Okay, so for that 120, there's your 120 deaths from wounds, that's coloured in, shaded in red on her diagrams. So then how are we going to get, what's the radius we want for the preventable deaths? Well, we want to double the area. So the area depends on the square of the radius. So instead of doubling the radius, which will give us 4 times the area, we want to multiply it by the square root of 2. So that's the kind of the shape we're going to get. And imagine that the blue goes all the way to the centre. So we're looking at the total area, not just the bit we can see, but the total. And then for the other causes, well, that's 60. So that's, again, half of the red area. This time we divide by the square root of 2, and we get something like this. Now, you might say, this is a bit extreme, Sarah, because, look, your preventable diseases, that's 240 of every 1,000 men. These figures are a bit, silly in this toy example, because that would imply that like a quarter of the army would die every year from preventable diseases. Well, the silliness of it is actually because it was way, way, way worse than that. Way worse. So, example, the worst month, January 1855, 85 in that single month, the mortality rate from preventable diseases was 85 in every 1,000 men, which over the course of the year would actually correspond to 1,023 for every 1,000 would die of preventable diseases, which sounds ridiculous, But that was, if nothing was done, right? So luckily something was done. But you could have something like that every month, because of course it's not necessarily the same. The army of 40,000 is not the same 40,000 men. You replace and you bring in new people. So you could have that. And this is true. It's not a mistake in the figures. So these terrible, terrible death rates. And this is what's plotted on the diagram. We can see there's January 1855. Just an appalling number of people, appalling mortality rate, I should say, of these diseases. So what happens between Circle 1 and Circle 2? Right at the end of March 1855, the Sanitation Commission arrives, and they start cleaning up the sewers and fixing the drainage and sorting things out. And from that, you can see straight away there starts to be an improvement. And by the time you get round to the next year, the blue areas, which is preventable diseases, have shrunk away so much that you can barely see them. So this is a huge success story. But what Florence Nightingale needed to get across to people was this is the result of that cleanup operation. So we know there are diseases are always with us, but we can change the outcomes, we can change the mortality rate. It's not just God's will that so many of these people will die. So this was an incredibly powerful and successful diagram that made the case for sanitation reform, not just in military hospitals, not just in public hospitals, but actually in society more generally. So she pressed for kind of acts of parliament that would require proper drainage in cities so that we can, with this cleaning up places, you can reduce these diseases. So I have to say, she did not invent this kind of diagram. She did not invent polar area diagrams. But let me show you what I think is the first kind of polar area diagram drawn. So we mentioned this chap, André-Michel Guéry, earlier with his Royal Statistics of France. This was from an earlier publication of his, 1829, and mostly it was about meteorology. So these may be the first polar area diagrams that appeared in print. Now they're all right. Yes, he gets the credit for perhaps being the first, but they're not sending a message, they're not telling us a story in the way that Florence Nightingale's pictures were. So the top ones are about the proportion of the time that the wind was blowing in a particular direction at a particular time of year. Okay, and the bottom ones are about numbers of people dying at particular times of day. Well, our first question would be, what's happening at midday and midnight? These are particularly auspicious times, or was that just the shift change at the hospital? We all know if you're in any hospital at 8 p.m. or 8 a.m., nothing happens for an hour. So maybe this is that. Maybe this is just telling us when the shift changes at French hospitals in 1829. I don't know. But these diagrams, they are not telling, they're not a call to action in the way that Florence Nightingale's were. And so I think her charts, she's put them to amazingly good use. I want to, in the last few minutes, give you just a few more examples of diagrams and charts that Florence Nightingale used. And again, she didn't just, not all her diagrams are polar area diagrams. She wasn't a one-trick pony. She would choose the right diagram for the right situation and get her message across. So let's have a look. So this is a very strong diagram. So this is what she called it a bat wing diagram. And you can literally see the shadow of death on this diagram. It's very powerful imagery. It's the same, more or less the same kind of information that she was giving in the polar area graph. Here it's the annual rate of mortality per 1,000, but kind of from all causes, and we can see it going around the circle. So at this time, it looks slightly different because she is the distance from the centre, so the radius, how far out she's gone, it's that's proportional to the number she's representing. So it's now not areas, it's kind of lengths, distance from the centre. And so what she's done is she's plotted a point for each month, and then she's joined them up. So it's sort of a circular graph. And you can really see very, very vividly just the horror of this time period with the mortality rate that she's got there. And on the left, year 2, again, you can see it's coming down feels like almost to nothing. And indeed, the worst month at Scutari, the mortality rate was 41% in that hospital. I mean, it's just unbelievable. And by the end, it was down to 2%, which is just an amazing transformation. In the middle there's a small circle that you can see. That is representing mortality in Manchester, kind of a not a beacon of health, right? At that time, it was an industrial town. There was lots of disease and poverty, but even then the mortality rate was tiny compared. So that was one of the things she did. She was very hot on looking at comparing mortality in the army with what's actually happening in the civilian population. Because surely the army is supposed to be full of kind of fit, healthy young men. They should not be dying of preventable diseases more than the general population. So this next diagram, this will appeal to the Victorian patriot. What have you got here? This is lines representing relative mortality of the army at home and the English male population. So she is comparing as much as she can like with like. Men in the army of the same age, look at the top one, age 20 to 25, men who are in the army and men who are soldiers. And they're not even at war. This is the army at home. So they're in their barracks at home. They're not fighting battles. And you can see, so it goes Englishmen and then English soldiers all the way down. And so the line for the Englishmen of that same age, it's half as long. The English soldiers, and surely deliberate to have the English soldiers be a thin red line, right? Goes in with that kind of iconography, the patriotism. You're supposed to look at this and be appalled that the English soldier, the thin red line, they are dying, even when they're at home. This is shocking. And this was a call to action, and that action did indeed happen. Why might this be the case? So we talked about sanitation. Overcrowding is also inimical to health. And she showed this in a really brilliant diagram. So these are kind of honeycomb diagrams, hexagons, showing how much space each person has in particular situations. So I'll just zoom in on the right-hand side of this. So on the far left, you've got how much space each soldier has, kind of amount of yards per person in an army encampment at home. They're not at war, this is at home. Then in the middle, you've got the most dense district in England, which is in East London, where I live. That feels about right. And then on the right, just London in general, so the average for London. You can see, look at so much space that the Londoners have on average compared to the soldiers, and even compared to the most densely occupied, poorest urban areas. And so this is a clear thing. You can really clearly see this with this clever choice, this inspired choice of a honeycomb showing with hexagons how much space you have. And of course, those guys are not going to be as healthy as these guys. So here's a little one that's almost like a tribute to her friend, Sidney Herbert. So here we've got 3 bars. So the total area of the rectangles in each case is the total deaths annually per 100 living from all causes, and then it's divided up into what the causes are. So the one at the top is the English male population, so these are the best comparators to soldiers, age 15 to 45. And you can see, what various things they're dying of, zymotic diseases, so these are the preventable diseases that we're talking about. The next one is, this is how Lord Herbert found the army. It's awful. Twice as, the mortality rate is twice as high for these preventable diseases, and all other things contribute to a large mortality rate. And again, I emphasize, these are infantry serving at home. This is not them being killed in action. They are serving at home, but they are dying of these diseases that are preventable. And then the bottom one is, this is how Lord Herbert left the army. So, with the input of improvements, which campaigned for by her and others, working with statisticians like William Farr, and then Sidney Herbert puts those things into action, and you can see the huge, huge improvement by the end of his tenure. So Florence Nightingale, her contributions, she knew how to argue for good data. She spotted when the data wasn't good and argued for it to be improved. She knew how to interpret that information and draw the correct conclusions, the right conclusions, valid conclusions, and her particular genius, showing those conclusions in diagrams that were so compelling that you could not ignore the conclusions. And she really believed this as a religious duty. You've got to make things better. And how do you do it? To understand God's thoughts, we must study statistics, for these are the measure of his purpose. And she continued campaigning for the whole of her life for not only for improvements in nursing, but for improvements in sanitation, in hospitals and outside of hospitals. Her work was instrumental. It saved thousands and thousands of lives. the legislation that was introduced following kind of her campaigns around public health transformed life expectancies in the UK. She was actually bedbound for most of her later life, but she's still the picture of her. She's got a rug on her, she's sitting in a chair, but she's got her correspondence. She continued campaigning, writing letters, through her life. She died in 1910, in August 1910. She was the first woman fellow of the Royal Statistical Society. She was the first woman to be awarded the Order of Merit, and as I say, an icon in her lifetime and beyond it. She's the second of three figures that I've been talking about in this part of my series of Gresham lectures of unexpected mathematical lives. So last time, you can go and check this out online if you want, I talked about Christopher Wren, architect, but also mathematician. We've now talked about Florence Nightingale, nurse, but also mathematician. So my next month, who I'm going to talk about, well, Alan Turing. Okay, mathematician, but also mathematician. So we think of Alan Turing, when we remember him, we mostly think about his pioneering work in the mathematics of cryptography and early computing. But he also did pioneering research and thinking about mathematical biology. So it's that I'm going to talk about next time on June the 6th, and I hope to see you then. Thank you very much.
Thank you so much, Professor Hart. I've got a couple of questions from online, and then perhaps we can go to the room. First question is, who invented the bar chart?
So I did have a picture from William Playfair up there in his political atlas, and I said it wasn't the first bar chart. Now, there's some discussion, speculation about this. Online, you will often find it claimed that Playfair invented the bar chart and the pie chart, but I don't think he did. So there's some very, very early things that maybe look a bit like bar charts, but I don't think they are, dating back a few hundred years. But I think there is a good case for a particular book that had a graph, well, a bar chart, it looks like a bar chart to me, of its water levels in the Seine. So in Paris, water levels of the river, high watermark, low watermark over the course of the year, and the bar chart covered kind of 30 years worth of data. And I think that precedes what Playfair did by maybe a decade or so. So there's a contender there, but I would be delighted if anyone were to be able to come up with an earlier bar chart. So that's your homework if you want to attack it.
And a very quick follow-up one. What's your favourite bar chart?
Oh, well, how does one choose? It's like choosing your favourite chart. I mean, I do like Playfair's one that I showed because it's giving this information, but it's also superimposing this graph. And that was the first time, I think, that you get this time series sort of situation where you're following these two variables. So I think that's got to be a contender.
How did Florence Nightingale acquire her mathematical and statistical education?
Right, yes, great question. So she had some kind of education from her father, who taught her a little bit about both politics and some mathematics and statistics. She also had a tutor, and there's some speculation that may have been a mathematician called Silvestri, if I remember rightly. I don't think this person necessarily taught her mathematics, but she was friends with Ada Lovelace when they were children. So, who knows? I would love to know what they talked about, whether they did any exciting mathematical thinking together. But so she picked things up a little bit along the way, but then she did work as well with statisticians. So I mentioned William Farr, and there were others with whom she worked when she was putting together these big, lengthy reports. So she wasn't absolutely isolated doing this stuff. But, the impetus was hers to communicate these things. And actually, William Farr, I think it was, said to her at some point, this stuff is statistics should be dry as possible. He said, because it's sort of just the facts, ma'am, kind of thing. You don't want to colour it with any kind of, emotions. But that wasn't what she was trying to do. She was saying we've got to get this information across. So she was against it being dry, thankfully for us. Yeah.
Professor Hart, thank you for such a fascinating lecture. I'm sorry, I don't think we have time for any more questions today, but thank you very much, and don't forget to come to her next lecture on the 6th of June.